Greetings of peace and wonderful day. Always start your day with a prayer. Have day full of blessing. It's a new day. Fresh start, fresh energy, new opportunities. Get your mind right, be thankful, be positive, and start your day right. Hi, I am Jomari B. Baranda, Tribe 1 Hypocycloid leader. Before we are going to discuss the topic, including the variable, language of sets, language of relations, and function, let me share to you first the aim of the title, speaking mathematically. Because without knowing the purpose, rather the aim of the title, we cannot clearly understand those topics. Speaking mathematically, the aim of this chapter is to introduce you to a mathematical way of thinking that can serve you in a wide variety of situations. When you start on mathematically problem, you may have only vague sense of how to proceed. You may begin by looking at examples, drawing pictures, playing around with notation, rereading the problem, to focus on more of its details, and so forth. The closer you get to a solution, however, the more your thinking has to crystallize, and the more you need a language that expresses mathematical ideas clearly, precisely, and ambiguously. This chapter will introduce you to some of the special language that is foundation for much mathematical thought, the language of variables, sets, relations, and function. Its goal is to warm up your mental muscles so that you can do your best. Again, I am encouraging you to appreciate math and love math because math is easy if you had a passion for it. Take note. In order to understand mathematics, we should change our perspective. That would be all. Thank you.
Variables comes from the Latin word variabilis, with varius meaning various and abilis meaning able or capable of changing. Variables, it is represented by a letter like X or Y, a symbol of a value we don't know yet.
Is 1 plus x equals 3. Sa example natin ng 1 plus x equals 3, alin dyan ang variable? Kasi, di ba ang variable is a letter that represent an unknown number. So, ang unknown number natin dyan sa 1 plus x equals 3 ay si x. So, it means si x ang variable natin. Next example, I will show you on how to represent a statement using variable. So, here's the example. Is there a number with the following property? Doubling it and adding 3 gives the same result as squaring it. So, eto na siya. Is there a number x with the property that 2x plus 3 is equals to x squared? So, ang given natin dito sa statement na to is yung number. So, hindi natin alam kung ano yung value ni number. So, ang gagamitin natin is si x bilang mag-represent dun sa number. So, with the property that doubling it is multiplying by 2. So, eto na siya. 2x. Adding 3 gives, eto na siya, yung plus 3. And, same result as squaring it. Eto. Is equals to x squared. Ayan na siya. Ito yan, yung same result as squaring it. Pag nirepresent natin siya sa using variable, magiging x squared. So, yung statement natin na Is there a number with the following property? Doubling it and adding 3 gives the same result as squaring it. Is magiging ganito na siya pag inirepresent natin siya using variable. Is there a number x with the property that 2x plus 3 is equals to x squared? As you can see in the example, we are representing number using empty boxes. We use empty boxes, so it means empty siya. So tayo ang maglalagay kung anong value ang dapat na ilagay natin sa empty box na yan para masatisfy natin yung equation. For the second use of variable, we need to consider the statement. No matter what number might be chosen, if it is greater than 2, then its square is greater than 4. Introducing a variable to give a temporary name to the number you might choose enables you to maintain the generality of the statement. Our example is there a number x with the property that 2x plus 3 is equals to x squared? No matter what number or any number that we choose, kung ang x mo ay mas mataas sa 2, ang square niya or yung result natin is greater than 4.
Sentences using variables. Are there numbers with the property that sum their squares equals the square of their sum? Solutions. Are there numbers x and y with the property x squared plus y squared is equal to x plus y squared? We can represent these numbers as plural siya. First, square lang natin yung first and the second numbers. Then, add natin yung dalawa. So, the sum of their square, x squared plus y squared is equal to the square of their sum, x plus y squared. Or, are there numbers x and y such that x squared plus y squared is equal to the square of their sum? We can replace the phrase with the property using such that. Or, do there exist any numbers x and y such that x squared plus y squared is equal to the square of their sum? Yes, there is. We have different ways of writing sentences using numbers.
Universal conditional statements. Universal statements contain some variations of the words for all, and conditionally statements contain versions of the words. If then a universal conditional statement is a statement that is both universal and conditional.
Universal existential statement that is universal because its first part says that a certain property is true for all of a given type, and it is existential because its second part asserts the existence of something.
History of the language of sets. Use of the word set, a formal mathematical term, was introduced in 1879 by George Cantor, 1845 to 1918. For most mathematical purposes, we can think of a set intuitively as Cantor did, simply as a collection of elements. For instance, if C is the set all countries that are currently in the United Nations, then the United States is an element of C. And if I is the set of all integers from 1 to 100, then the number 57 is an element of I. Set language is a mathematical way of representing a collection of objects. In our daily life, we often deal with collection or objects like books, stamps, coins, etc. Set language is a mathematical way of representing a collection of objects.
Set defined. A set is an object defined as a collection of other distinct objects known as elements from the set. The element of the set can be anything: people, plants, numbers, function, and even other sets.
Set and its element. A set is a collection of well-defined and well-distinguished objects. The objects that makes up a set are called members or elements. What do you mean, what well-defined? Example, I have here a set A vowels can easily list the elements na tinatanong. So, the set of vowels is the English alphabet. So we have A, I, O, U, a set B of plain figures, a set C, A, U, A, G. The set of elements in a periodic table. So are those examples of well-defined members or elements. So ang tawag natin doon sa mga makikita natin sa loob ng set ay members or elements.
A set of real numbers is usually featured as the set of all points on the line, as shown. The number 0 corresponds to a middle point called their origin. A unit of distance is marked off, and each point to the right of the origin corresponds to a positive real number found by computing its distance from the origin. Each point to the left of the origin corresponds to a negative real number, which denoted by computing its distance from the origin and putting a minus sign in front of the resulting numbers. The set of real number is therefore divided into three parts: the set of positive real numbers, the set of negative real numbers, and number 0. Note that neither 0 is positive nor negative.
Existential universal statement. An existential universal statement is an statement that is an existential because its first part asserts that a certain object exists, and is universal because its second part says that the object satisfies a certain property for all things of a certain kind.
Examples: given that R denotes the set of all real numbers, Z the set of all integers, and Z positive the set of all positive integers. Describe each of the following sets. Letter A. This is the set of all elements in the set of integers such that x is greater than -2 but less than +5. So, this is the set of all elements x in real numbers such that x is greater than -2 and less than 5. So, ibig sabihin yung elements daw natin ay mas mataas sa -2 pero mas mababa sa 5. So, this is the open interval of real numbers between -2 and 5. Pag sinabing between, nag-meet sila sa gitna. So, it is pictured as follows. I have here our x daw, our elements ay mas mataas sa -2. So, kung mas mataas siya sa -2, pa-right yung graph natin dyan. And then, mas mababa sa 5 pa left naman. So nag-meet sila sa gitna kaya between. Now, -2 and +5 are not part of elements in a given set. Bakit? So as you can see, nung pinakita natin siya sa illustration, it is not solid. Okay? It is hollow. That means empty yung circle natin. Ibig sabihin nun, hindi siya kasama sa elements.
This is the set of all elements in the set of integers such that x is greater than -2 but less than +5. Ang elements daw ay mas mataas sa -2 but less than +5. So ito naman ngayon ay set of integers. Since ang hinahanap nga ay set of integers between -2 and +5, so the answer is equal to the set of -1, 0, 1, 2, 3, and 4. Another example, the set of elements in x in positive integers such that x is greater than -2 but less than +5. Pareha sa pangalawang example, ang hinahanap ay integers between -2 and +5. Pero dito, ang kukunin lang ay yung mga positive since ang hinahanap ay positive integers. So the answer is equal to the set of 1, 2, 3, and 4. Kung mapapansin nyo ay nawala yung -1 and 0. Kasi nga, yung kukunin lang ay yung mga positive integers between -2 and +5.
What is relation? Relation is any set of ordered pair numbers. Example, the pairing of the student number and his corresponding weight is a relation and can be written as a set of ordered pair numbers. Like W equals the quantity 1 and 120, 2 and 100, 3 and 150, 4 and 130.
The set of all first elements is called the domain of the relation. The domain of W equals 1, 2, 3, and 4. The set of second elements is called the range of the relation. The range of W equals 120, 100, 150, and 130.
Another example of relations. A relation of a set of ordered pairs. R equals quantity 1 and 5, 2 and 4, 3 and 6, 4 and 8, 5 and 10. The 1, 2, 3, 4, 5 is the domain, and the 5, 4, 6, 8, and 10 is the range.
Function can be represented as table, graph, mapping diagram, as for example, given this ordered pair.
So, we have here the ordered pairs negative 2 and 1, negative 2 and 3, 0 and negative 3, 1 and 4, and 3 and 1. It can be represented as table. As you can see, we have here the table of x and y. The table x from the given ordered pairs are negative 2, negative 2, 0, 1, and 3. And the table y is 1, 3, negative 3, and 1. And for the graph, you just have to point it out where the points are, just for example, the graph that's shown on the screen. And lastly, for mapping diagram, just connect it to the number that it pair from the ordered pair. And that's how we represent a function.
What is a function? A function can be defined as a rule that relates every element in one set, called the domain, to exactly one element in another set, called the range. For example, y is equals to x plus 3 and y is equals x squared minus 1 are function because every x value produces different y value.
In evaluation or relation, what we're going to do.
Function can be represented through equation. Here is the example. Q of x equals x squared minus 2x plus 2 when x equals to 2. We will substitute all the x by 2. Kaya naging 2 squared minus 2 times 2 plus 4. Then ita-times natin siya. 2 squared equals 4 minus 2 times 2 equals 4. Then copy natin yung 2. Ibaba natin. So magiging 0 plus 2. Ibig sabihin, q of 2 equals to 2. This only means that the equation is a function.
In general, a relation can be determined as function if no x value is repeated twice. And take note that if the equation is linear or quadratic, it is function. But if the equation has 2 squared like 2x squared plus y squared